These are Module 4 question examples for the DBA. Right on this first one, we're going to look at, this is asking us to solve the system of equations by graphing. So we're just going to graph the two equations. In this first one, our slope is 1/4 and our y-intercept is +2. So I'm going to put a dot here at 0, 2 for our y-intercept, and our slope goes up 1 and to the right 4, and that's going to be right there. So we're going to put another point right there, and we can also go down 1 and to the left 4 right there. And now I'm going to connect those with a, it's going to be a straight line going right through those, like that. And the next one, we're going to have a slope of 3/2 and a y-intercept of -3. Y-intercept of -3 will be right here at 0, -3. And then a slope of 3/2 means go up 3 and to the right 2, up 3 and to the right 2. And just keep following that pattern. So we're going to have points here and there, and I can connect those with a line. And it continues on, and what I notice is that the point of intersection is right here, and that appears to be the point 4, 3, which is my solution. On the next one, we're going to need to solve these equations for y. So here, I can subtract x. I'm going to go up a little bit more here. Subtracting x from both sides, I get -y is equal to -x minus 2. And now I'm going to multiply through by -1 on all of these. So I'll get y is equal to x plus 2. That's by multiplying through by -1. And then here, I'm going to subtract a 6x. So I'll have -y is equal to -6x plus 3. And again, multiplying through by -1, get y is equal to 6x minus 3. And now I'm going to notice that my slope here is a +1, and my y-intercept is a +2. So I will put a point at 0, 2, and my slope is 1, which means go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1. Either one of those works, and then I can connect those with a line. There we go. And the next one here, I have a slope of 6 and a y-intercept of -3. So I'm going to start out with my y-intercept there at 0, -3. And a slope of 6 means go up 6 to the right 1. Right there. And that's going to be, just connect those points. That's right where it crosses the other line. So again, where they cross, that's my solution. So my solution here is the point 1, 3, and I can put that kind of anywhere, and that is my solution. Solve the system by substitution. So that means I'm going to take this, and because it equals y, I can plug it in for that y right there. And so what I'll get is 2, what I get is 2, I'll get it right, 2x plus 2 is equal to -3x minus 8. Now I'm going to solve by adding 3x to both sides, and I will get 5x plus 2 is equal to negative 8. The next step I'm going to do is going to be to subtract 2 from both sides, and I get 5x is equal to negative 10. Lastly here I can divide by 5. I get x equals negative 2. Now I'm going to need to substitute my solution there into one of my other equations, one of my two original equations. Either one, doesn't matter. I'll use this one. And I'm going to just make a note that that's my solution in blue, so when I substitute it in, it'll be in blue. So we have a y is equal to 2 times negative 2 plus 2. That's y is equal to negative 4 plus 2, and y equals negative 2. So my solution, and I can, let's see, I'll make that one purple. Y is equal to negative 2. So my solution is negative 2. Oh, look at that. It's negative 2, negative 2. What a coincidence. The x and the y are the same. Does not have to happen that way, of course. Alright, now, here, we're going to take our, this equals y, so we're going to substitute it in for y right there. So, here we'll have, let's go down below here. We'll have negative 8x minus 7 times negative 5x minus 16, when we do that substitution, is equal to 4. Now I'm going to need to distribute this negative 7, so we'll get negative 8x minus negative 7 times negative 5x is positive 42x, and negative 7 times negative 16, let's see, that's going to be 112, I believe, plus 112. Hope that's right. I think it is. And that's going to be equal to 4. Now I'm going to combine the negative 8x and the positive 42x to get a 34x plus 112 is equal to 4. Next I will subtract 112. When I do that, I'll get 34x is equal to negative 108. I think maybe I made a mistake there on my calculation. Let's see. 7 times 16 is 112. Oh, that's right. All right. 42 minus 8 is 34. Yeah. 108 divided by 34. What? Boy, I'm not really sure what's going on here. There's something that seems weird. Huh. Well, let me see. I'm going to do something real quick just to double check, see if I made an error somewhere. Yeah, it's going to be a whole number, so where did I make an error? Let me go back. I have the negative, so I'm using this equation and substituting all this in for y. So I have negative 8x minus 7 times the quantity negative 5x minus 16 is equal to 4. Negative 8x plus, right here, this is it, right there. Because negative 7 times negative 5 is positive 35. And that is what happens when you do math too tired, my friends. But that's what you do. You go back and you check it out and you see what went wrong, and I figured it out. So now it's negative 8x plus 35 is going to be a positive 27x. And now that looks better, because when I divide both sides by 27, I get 4, negative 4. And so that is going to be my solution for x. Now what I need to do is I need to take this and I'm going to plug it into one of my equations, and because I need y, I will use this equation. So I'm going to get y is equal to negative 5 times negative 4 minus 16, and that's going to be 20 minus 16, and y equals 4, and so that's going to be my y value. So my solution is going to be negative 4, positive 4. Alright, that's that. Solve each equation by elimination. Now this one's real nice because these are lined up and they're one's positive, one's negative. So when I add these two equations together, it's going to eliminate the x's automatically. So I have a positive 3x plus a negative 3x is going to be 0x. Negative 6y plus a negative 4y is going to give me negative 10y. And 9 plus 11 is 20. Now I can divide both sides by negative 10 to isolate my y value, and I get y is equal to negative 2. So I'm going to say there's my solution, and then I'm going to take that along with, doesn't matter at all which one, so I'll take that, 3x minus 6 times negative 2 when I plug in my solution for y in there, and that's going to be equal to 9. Now that negative 6 times negative 2 is going to give me a positive 12. Now I'm going to need to subtract 12 from both sides. When I do that, I have 3x is equal to negative 3. Dividing by 3, I get x equals negative 1. And I'll take that right there. So my solution is the point negative 1. Oops. And negative 2 is the y value there. That's my solution. This one is not as nice because I'm going to need to do some multiplication, but it's not too bad. I see that here this is going to be, I can just multiply this first one by a 2 or a negative 2. It doesn't matter. Well, I'm going to need to subtract in one case or add in the other. So I'm going to take this equation and I'm going to multiply that by a negative 2. And when I do that, I'm going to get negative 18x minus 8y. I'm just multiplying every term by negative 2 is equal to 26. This one I won't change at all. Negative 8x, and there's exactly the reason right there. That's why I didn't need to do anything. So now I'm going to add these together. And when I do that, I'll get negative 26x is equal to 26. I can simply divide by negative 26 to isolate the x, and I get x is equal to negative 1. Now I need to plug that x equals -1 into one of the equations, and I think I will plug it into, I see something that's going to happen. I'll take that and this, so I have -8 times -1 plus 8y equals 0. So now that -8 times -1, that's +8, plus 8y equals 0. Now I'm going to subtract 8 on both sides, and I will get 8y equals -8. Divide by 8, and I get y equals -1. And seems like that's happened a few times here, where there's been a situation where the x and y value are the same. It's just a coincidence here. Nothing more than that. Sorry about that. There you go. And that's the solution for number 6. 2 more. I know this is going on pretty long. Thanks for sticking with me. I'm going to graph these ones pretty quickly. We have I'll just make this one an orange one, and I'll make this one a green one. Now this is going to be a solid line because of that equal sign, and this is also going to be a solid line. So the orange one, we have a y-intercept at +0, 2, and a slope of 1/2, up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2, down 1 to the left 2, and connecting those with a solid line. And now this tells me to shade above the line when it's opening towards the y value. It says we shade above the line, so that means that up here is our solution set for that one inequality. Now for the other inequality, we have a y-intercept of -1 and a slope of 2, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, down 2 to the left 1, down 2 to the left 1. And again, that's going to be a solid line connecting those dots. And because our inequality is opening toward the y value, we're going to shade above the line, so that means up here. So here, the solution set for the inequality is where those two solution sets overlap. So the area that we're actually interested in, that is the solution set, is right up here. This space up here where it's double overlapped. This is just the orange in here. This is just the green in here. Neither of them, this isn't the solution set for either of them. So the solution set for the system is up here. And it also is the lines because they're solid. Last one here. All right. So for the orange inequality, we have a y-intercept at 0, 3 and a slope of 1 because there's no number shown there, so that means it's a slope of 1. So I can put in all those points. And it is a solid line. So just connect those with a solid line. And this time the inequality is opening away from the y value. So y is less than that line. So that means that we shade below the line. So down here. So all of this is the solution set for the first inequality. Now we have the green one we need to do has a y-intercept of -3 and a slope of -5. That means I need to go up 5 and to the left 1. I could go down 5 and to the right 1, but that would take me off of the graph. So I go up 5 and to the left 1. So right there. And then that's going to be a dotted line because there's no equality there. So and then because we are opening toward the y is greater than that, so it's going to be shading above the line, and so that will be over here. Whoops. Sorry. Now I didn't include my arrows there. Goes on forever, of course. And so my inequality shading will be over here. And so once again, the solution set is where we are where we're overlapping our two shaded regions. Any of the points on this line are included in the solution set because it's solid, but the points on this line are not. But any point up really close to that line is part of the solution set. And so that, my friends, is the Module 4 DBA example questions. I hope you found that useful and that you do great during the DBA.